All right, so this is kind of going to be uh, a little hodgepodge wrap-up lesson today. Yeah.
We're backing up. We were in 5.4.
I wrote the wrong number. Thank you.
Oh yeah, we were in 5.6.
It's 5.7. I was thinking calculus. They're in chapter 4. All right, so we're going to learn to write the equation of the trig. And again, like I said, we're going to start with the concept that y equals a trig word, omega of x minus phi plus b is our generic formula that we can turn into any trig. Because we know A is the amplitude, we know B is the up and down number, we know omega helps us figure out the period on whether it stretches and compresses horizontally, and we know that whole parentheses has something to do with shifting right from left. So, we're going to do a sign example first. Okay, let's see. Oh, well, that's really bad T there. I crossed in the wrong place. I forgot to write the number. Okay, so this is the original information that you would be given possibly on a multiple choice question on your state exam, in which you know certain things go back in this formula in certain places. Now, we've not been calling it this, but I found this in some textbooks. They call the up and down a vertical shift. So phase shift goes left, right, vertical shift goes up and down, because vertical's up and down. So basically, you're just trying to figure out how to put all this back in there. Okay? So let's start off with, you have to know which trig word goes in your problem. That's pretty obvious. Everybody agree? In front of that is supposed to be something that tells you what? A stands for what? Amplitude. Is my amplitude positive or negative? Negative, because it reflects. Does that make sense so far? Now, my period is 2 pi. How long sine's period supposed to be? 2 pi, right? So if you divide 2 pi by something and you get 2 pi back, if it's 2 pi divided by omega, then omega has to be a 1, right? 2 pi divided by 1 keeps 2 pi. So you're right, it's just x. Did it have any right-left shift? Then I don't need a parentheses. Up and down? Minus 2. How do you think about this so far? The tricky part is dealing with that parentheses. That's the only tricky part.
Can you put a parentheses as long as it's just...
Yeah, you can put a parentheses if you'd like. It is not wrong to write these parentheses. You'll just never see them. But you can write them. All right, let's look at a second example. Okay, we're going to do a cosine example. And I'm going to go through these functions kind of in a certain order, y'all, because tangent, cotangent are a little different. So we'll focus on the others first, and then we'll look at tangent and cotangent. Wait a minute, I wrote the wrong number there. Oh, I got off one. Okay, here we go. Yeah, that's it. So in this problem, we're going to have phase shift. There's not going to be any reflecting, but I threw phase shift in so we could see what is that effect. And also, we have, in this particular situation, the same kind of information we had before, but we're going to have to really focus on period and phase shift. They cause the most trouble with making the formula. Not that it's hard, it's just not obvious sometimes. Okay? So I'm going to show y'all a couple of things that can help you to get that. And then if that don't get it, we'll just have to do some math to work it out, because it won't be something you just look at and got the answer. All right. So first of all, we're doing cosine, so we're going to put cosine's abbreviation in there. What goes in front of it? Everybody agrees, right? We're going to have a parentheses I'm coming back to. Do I need a number on the end this time? That's right. This is your A, this is your B. So you can go ahead and fill those two things in first. Always. Always deal with your reflection, if it's over the x-axis, your amplitude, and your vertical shift. Do those first, because they're all outside. Now I'm going to ignore period first, because I have a phase shift. Okay? Someone solved the problem x equals negative 4 pi over 3. We need to get it back equal to 0. Not exactly. But we need it equal to 0, so in order to get it equal to 0, wouldn't I just want to add it to the other side? I still might want to do something with that thought, but keep that thought for a minute. Right? Everybody with me? Now, if that was my parentheses, then my omega would be 1. Is omega 1? So we've got to go back and multiply this by 3. Because that's what somebody did when they solved it. They subtracted and they divided by 3. So we got to undo that. So we added and we multiplied by 3. Does that make sense? So we're kind of doing the opposite, but we're not flipping the whole thing, because we got to get those two numbers separated so that the 3 is only the omega. Does that make sense? Okay. So now we know 3x plus 4 pi. And then you could go back through and you could pretend you're pulling them out and make sure you put it all in the right place. Right? All right. All right. Now let's look at a secant example. Not doing as much doesn't mean it's going to be just real straightforward sometimes. So until you've seen each one, you don't really know what makes it more complicated. But I'll tell you, phase shift does make it sometimes more complicated, especially if the period's not matching up real well with that. All right. So obviously with my secant word, if I put my word in here, do I need something in front of secant? Why not? Right, the amplitude's 1, and it looks like there's a 1 in front if you don't write 1. Everybody agree? Do I need something after my parentheses in this problem? Yes, the vertical shift of going down 2.5, and granted, normally we don't write decimals, but sometimes state test questions use all kinds of numbers just to try to trip you up into thinking there's something wrong. They could also change that to -5/2, and instead of writing the decimal, and you just have to be aware of look for what looks similar. So let's talk about this period. All right, so if period is equal to 2 pi divided by omega, then I would set pi over 2 equal to 2 pi over omega, and I would cross multiply and solve, because I need to know what W is. Or 1/2 changes to 2 over what? 4, because we just know how fractions work. So you have two ways you can get that. You can think cross multiply and divide, or you can just think proportions with ratios and fractions, where 1/2 changes to 4, so W has to be 4. Does that make sense? Because it's the same thing I get if I did this. Pi W equals to 4 pi. The pi's cancel, right? So it's 4. Where does that go? Okay, 4x. Do I need any adding and subtracting over here? No, because there's no phase shift. So if there was phase shift, I focus on it first. If there's no phase shift, I focus on period, because it gives me that number in front of x. All right, cosecant. Okay. Oh, that's all it was. All right. So in this problem, we've got only amplitude, period, and phase shift. And those are the main three things. Most of the time, they're going to give you a lot of that. They didn't do any vertical shift. There's no up and down on this problem. So we've got to take these three pieces of information and fill in the number in front and the parentheses with nothing on the end. So we start off with what goes in front of the word cosecant. Does it need to be positive or negative? Now, let's focus on the phase shift. So, negative 3 pi over 2. If you move that over and make it equal to 0, what do you have to do to that? Add it. Now, once you add that, you have to stop and look at it and think, would it give me the right period to leave it that way, or do I need to go further? Okay? There's a 1 in front of x. 2 pi divided by 1 is 2 pi. I'm good. I don't need to move this number in front over here to the x position, because then it would be 2 pi divided by 2, and that wouldn't be 2 pi, would it? Sometimes you don't have to fix as much with that parentheses. Sometimes you do. Does everybody understand what I'm talking about there? I don't need to multiply by 2 because I don't want a 2 in front of the x. I want this to be equal to 2 pi over omega. So I'd have to have a 1 on the bottom for it to stay the same. Okay. Now, tangent and cotangent are a little bit different because their period is different. And other than that, I think that would be the only thing that might cause you to have to figure out, do I need something in front of x, what do I need, and that type of thing. Other than that, I think it's almost identical. We'll do tangent first. And I threw in y-axis for a reason. because I can. We may never say it does over the y-axis, but we can make our formula look like it did. So that'll be the last thing we probably have to think about once we get everything else situated. Okay? How much of it can I fill in right now because I just know? Okay. Y equals what? Okay. All right. 2.5 cotangent. We can do that immediately, right? Oh, excuse me, tangent. Thank you. I'm getting the cart before the horse. All right, tangent. I don't have any up and down, right? So I don't have to worry about that. So let's focus on our phase shift, because when you have it, you have to focus on that. So if x is equal to 2 pi over 3, what was it when it was equal to 0? All right, because we subtracted to move it back to the other side. Now, remember that period is pi divided by omega. So if I have a 1 in front of that x, is that going to make my period right? No. So that's why I'm going to times it by 3 to put that x number back in front. Now does it make my period work? Okay. So once I realize that's my parentheses, this is where I can now talk about the last piece. If I hadn't put this reflect over the y-axis part in there, I'd be done. But what makes it reflect over the y-axis is when that's backwards. Okay? So, right, so you just turn it around. And that makes it go over y. Does that make sense? Now, if I turn that around, bring the negative out, that's going to make it go over x, right? But if I leave it that way, supposedly that's going over y. Another thing that sometimes if you're doing a multiple choice test that can be very helpful, and like if you narrowed it down to 2 questions and you weren't sure which one was the right answer and you thought, well, they both seem so similar, you could always graph them both and then look at it and say, does it fit what it's supposed to? And I would use Desmos for that because it'll put those pi's down there if you put the scale in. All right, our last one. What if it is cotangent? Okay, the amplitude, period, phase shift, vertical shift, I put it all in this one. Why don't y'all try it and see if you can do it yourself, and we'll go over it. All right, so what did your formula start off with? 6, cotangent, okay. Okay, x minus pi over 2. All right, let's see if that makes sense. Number 1, if I pull that number off the front, that is the amplitude. If I pull that number off the end, that is the up and down vertical shift. Does that make sense? Okay, this is positive, so it makes sense on why it should be subtraction. Everybody agree? The period is equal to pi divided by omega. Would the number in front of x need to stay 1 to make that match? Yes. So I don't need to multiply that parentheses by 2 to get that 2 off the bottom. If this had been 1/2 of the period, I'd put the 2 in front of the x. Does that make sense? Everybody with me? All right. So the next thing we're going to do is we're going to look at graphs. We're going to look at one graph of each one of our functions. And as we do that, we're going to try to take that graph and figure out, based on what our knowledge is of what the pieces are, what would the formula be? Okay. Now, what can make that a little tricky is they don't just draw one piece of it. They draw the whole entire graph. And you've got to know where to start it and where to end it. Okay? So, in order to make that work, I really need some really good looking graphs, and I didn't have that much time this morning, so I'm going to freeze the screen just real quick and make one on Desmos, and so I can make a print of it and bring it over so I can write on it.
Get some water.
Yes, you can get some water. Anybody need to go to the bathroom while I'm doing this? That'd be a good time.
I left one page blank, or I don't know what reason. And I wrote it on that page, and now I have to transfer it.
Oh, honey, it's all right.
Okay, 5.5 due on Friday. When I was in here.
Uh-huh.
Okay.
Have you got it?
Yeah, I did.
Okay, that'd be great.
So we put
That'd be great.
hold up. Well, I didn't know that it goes to and I saw it was in high school and zero.
Yeah, well, that's why I put the zeros in, because I know you'll see it and you'll say, "Oh, I need to turn that in."
Took me like 5 minutes extra, but yeah, my hair took me like 2 seconds. Yes, I didn't brush my hair. I did like
No.
this, like this.
All right. I think this will work. If it doesn't work the way I want it to, we'll drop back and punt. All right, the first thing you have to do is ignore that there's some stray lines in the picture, because when I drew the box around it, it put some stray lines, see? Or there's a stray line. I don't know. There's another one. I have no idea. I don't know why they're there. Okay, so what we first have to figure out is what is the amplitude of our problem. So it looks like to me it went down to -2, -1, 0, 1, 2, 3. Well, it's not going by ones. How can I tell that? Because it says 2 right there. Every 2 boxes. So this is 3. This is 1. Maybe that's why those lines are there.
Oh, yeah.
Right? That might be why those lines are there. I don't know.
I didn't know which one was that. Oh.
All right. What is halfway between -1 and 3? I got to know that.
Oh, no. Yeah.
2. Okay. It's 1. Let me explain why. Because 3 plus -1 is 2. Divided by 2 is 1. It's the average. Now, the reason I need to know that is I need to cut my graph in half to figure out my altitude. Now, how tall is my altitude? Everybody agree? From 1 to 3 is 2. Second of all, is it sine, cosine, secant, cosecant, tangent, cotangent, just by the looks? Narrow it down to 2. It's sine or it's cosine because of its shape. It's a wave. I can make it work for either one of them. So since I can make it work for either one of them, I'm going to show you both, but I'm going to show you the one that would be more obvious first. Sine and cosine always cross the x-axis. Halfway between, they always cross the x-axis on y. Sine always crosses it kind of like in the middle of the curve. And cosine usually has one of these on the x or y axis. So if I had to choose one just from the look at this problem, I would think this right here is in the middle of the y-axis and that this would be sine. But I can make it cosine also. But to me, it looks more like sine, so I'm going to go with that. So we now know the amplitude is 2. So let's highlight one of our curves. And since I'm on this one, I think I'll highlight this one because I was already using part of that one. Reflect or not? Yeah, it's upside down, isn't it? It's supposed to go up and then come down. This is what sine looks like. So cosine looks the same, but it doesn't have the same position. Doesn't sine always start on 0 for x? Well, here's my x-axis, and there's 0 up whatever. So that's why it's 0. All right, so this is reflected because it went down first instead of up. Now, that line I put in the middle is very important. It's supposed to be on 0. That's why the numbers in your table are 0, 1, 0, -1, 0. Mine's not. How much up is that line from the x-axis? Okay, so this distance here is b. It's your up and down motion. From the x-axis, how much that line in the middle of your graph that cuts the graph into 2 equal pieces, it's called a midline. And that midline tells you what number to put on the end. If it was down, I'd put a negative number. So it's up 1. Now, how long is it from the y-axis over to the end of my graph for the first piece? That's the period. That's why I wanted to go from 0. Because if you're starting on 0 and going to there, it's 2 pi over 3.
Would you ever not start on 0?
I always count my period from 0, even if I'm doing a function that the whole piece isn't there. I still would start at 0 to see how long it is. It's just math's easier. I mean, I could have started over here at negative pi over 3 and said I went to pi over 3. Because wouldn't that look like a sine wave also? The problem is, then I'd have to take pi over 3 minus negative pi over 3, and I just thought that sounded hard. So I always start at 0 to figure out my period. All right. So if that's my period, what has to be in front of x? 3. Everybody agree? But I don't know if there's any right-left motion in this problem. So then I go back and I look at it. Is the end of my curve, I got 2 parabolas here. A sine wave's end is always on the y-axis, or it has to move off of it to be there. So since the end of my curve there is actually on the y-axis, I could say there's no left-right motion in this problem. So now, let's see if that makes sense. I'm going to erase everything I got written on here. And we'll see if it works. Pretend nothing's graphed up here. We're going to make a table, and we're going to see if it fits. Don't you always start with 0? Go by pi over 3 because that's the number divided into 2 pi, right? And then you, wait a minute, not pi over 3, 2 pi over 3. And if you divide that by 4, won't that be 6s for scale factor? Everybody agree? 6s. 1 6, 2 6s a third, 3 6s a half, 4 6 is 2/3. Everybody with me? No left-right motion, just those numbers. Over here, I'm supposed to have 0, 1, 0, -1, 0. Let's multiply it by -2 and add 1. So that's going to make that 1. That's going to make that -1. That's going to make that 1. That's going to make that 3. And that's going to make that -1. No, excuse me, +1. Let's see if it's right. Go over 0, up 1. Go over to pi/6, which would be in the middle of this, down -1. Go over to pi/3, up 1. Go over to halfway between here is 2 pi/2, and up 3. And come back, and there we go. It's my formula, doesn't it? Now, we're going to take the same problem, and we're going to make it fit cosine. Okay, cosine is the same shape, but your curve for cosine has to start either with going uphill or downhill, okay? The thing that you have to remember about cosine is that the top of the parabola should be here if it's not shifted left or right. Let me draw in the real cosine function here. The real cosine function, that's not quite right, but close. Kind of like that, where it's up 1, but the top of the middle here is in the middle. Does that make sense? Cosine has the maximum on the y-axis. Is my maximum on the y-axis? No, it's not, is it? It's either shifted to the right or it's shifted to the left. And we can do it either way. So I thought we'd just do right because that's easier. So we're focusing on this piece of the problem to figure out how far did it shift to the right to get this right here off of this axis and over there. Does that make sense? Everybody with me? I could also make an argument for going back. I also could have done sine differently, because I could have said sine was here. I can start wherever I want, y'all. It makes a different formula no matter where you start. So, I'm just suggesting pick the closest one you can. How tall is it again? That didn't change, did it? But now it's not reflected anymore because it went up first. Is it still 1 up to the middle of it? Yes, that didn't change. Just because I want to change my function does not change the A and the B. It might change whether it's positive or negative for reflect, but it did not change my A or B. What changes is what goes inside that parentheses, because now my problem has not only got a problem with the period, but it's got a problem with the shifting. Okay? See, my period from here to here is still 2 pi over 3, because it's pi minus pi over 3. Isn't pi minus pi over 3 2 pi over 3? So my period is still the same. That didn't change. But how far over to the right did I move? Pi over 3. Okay, right, pi over 3. Now keep that in mind for a minute. I'm going to set that equal to x. I'm going to move it over so it looks right. Do I need that 3 in front of this x to make my period work? Yes, I do. You mean drawn in really heavily? No.
We have to find that.
Yes, you have to find the midline halfway from the top to the bottom. Yes. So this one is 3x minus 2 pi. Same two formulas. If I put both of those in Desmos at the same time, they would draw the same graph. And I could make the coups of these, y'all. This is just 2 samples. Because I could have decided to do this problem from the get-go. I could have used that for cosine and made it go back. I could have used that for sine and made it go left. I just got to pick a curve and work with it. Does that make sense? Okay. Which is why sometimes they only show one piece of the graph, so that you're focused on what they want you to focus on. Let's do one with maybe secant and cosecant. And I'm just going to draw it out because as I realized trying to do it, it might be a little easier if I just drew it. Roughed it out here. That's the best I can do on that one, y'all. To make it really, really simple looking, but yet make it fit both functions. So this can be done with secant or cosecant. One of them's easier than the other one because you always have one that really fits the shape really well. That's where knowing what your function looks like is important, just like what I did with sine. Sine always has the, I don't know what y'all know about this, let me go back. That's an inflection point. An inflection point is halfway between a max and a min. Sine always starts on an inflection point. Cosine always starts on a max. Does that make sense? So when you're wanting to know if this is secant or cosecant, look at the y-axis. Would that be a max when I reflect it, or would it be an inflection point? A max. Because this is the reflection of sine or cosine. Once I realize that it's the inflection of a max, I know this was a cosine function that they turned into secant. Secant always starts on the max or min. Look. Where cosecant, a vertical asymptote would be here. Does that make sense? That's what you got to know the difference. Cosecant has a vertical asymptote here, where this one has a max or a min for secant. So let's do secant first. Now, how do I know what my amplitude is? Well, let's think this through. If I flip that back over, what would my amplitude be? And if I flip this back over, would it have the same one? Oh. So where that max or min is important, because that's your amplitude. Now, you got to be careful. If they're not the same, that means there's some shift up and down thing. And in that case, you would have to add the two numbers together and divide by 2 and find the midline. I don't need the midline because this is in the middle. Think about it. What is 2 minus negative 2? 4 divided by 2. Amplitude is 2. Try that again. 2 and negative 2 are the tops and the bottoms of these two things. 2 minus negative 2 is 4. Divided by 2 is 2. Therefore, my midline is here because it's 2 up and it's 2 down. Does that make sense? That line in the middle is the amplitude from the two items. So it's 2 to get to there, it's 2 to get to here, so the amplitude is 2. Did it shift up or down with my midline? No, my midline's in the middle. My midline is actually on 0, so there's no number on the end. Does everybody see that? Now let's talk about right-left shift. For it to have a right-left shift in this problem, the minimum will not be on the y-axis if there's a right-left shift. So I don't have a right-left shift, do I? Does everybody see that? Cosecant always starts with a minimum. So unless the minimum's not on the y-axis, you didn't shift left or right, because it always starts on a minimum. That's when we have to back up one line when we do secant, because we want to get the part that's over here and not start in the middle of a graph. So in that case, I know there's no left, right, there's no left, right. So all we got left to deal with is period. Now, period starts on the first dotted line that has the parabola that's up, to the next one, to the next one that goes down. How far is it from there to there is my period. So period, in this case, is 2 pi minus minus negative pi, because you subtract the bigger minus the smaller. Isn't that 3 pi? Now think about that. If it's 2 pi long on this side and it's pi long on this side, it's got to be 3 pi, right? Okay. Now, we know that period is 2 pi divided by something, gave me 3 pi. But not 3w, 3 pi. I don't know about you, but how do you divide 2 by something and get a bigger number? I guess we better learn to do the math. This one's not something obvious, is it? So let's cross multiply. 3 pi w equals 2 pi. The pi's cancel out every time. 3w equals 2. Divide by 3. W is equal to 2/3. Let's see if that makes sense. Let's do the math forwards now and see if that's the right answer. Don't you take 2 pi divided by 2/3. Doesn't that mean flip and multiply? If I made a math error, we'll find it. Sometimes I do it backwards in my head. I think this is right. So you're going to flip and multiply. Don't the 2's cancel out? What did I end up with? What I want. So the key here is you've got to set the formula 2 pi over omega equal to whatever you come up with is the length of the whole graph for one piece. And solve for your own W. Because it's not obvious. 2 divided by something made 3. That's just not obvious. Now, there's no right, left, there's no up, down, I'm done. Now we're going to take the same problem and we're going to twist it and we're going to turn it into a cosecant problem to see how is cosecant different. Now we might actually get to use some pieces of this problem a second time. Not many, but I've got a few. It's really hard to find these. There's just not a lot of this out there. There's more of sine and cosine. There's lots of those. But there's not a lot of the other ones because sine and cosine is the most important. All right, so looking at what I have here, I want to talk about cosecant. Cosecant's graph, when you look at the real graph of an XY cosecant, looks like this. Does everybody see what I'm talking about? It's all on one side of the y-axis. Mine's not all on one side of the y-axis with the up piece. Does that make it look like it shifted left? So there's a piece that would be different in my formula because it shifted left. All right. Is it still 2 above and 2 below? Yeah, that didn't change. But what's going to change is that parentheses because I want to shift it left now. But I still want it to be 3 pi long. That didn't change either. But I want it to shift left. So we're going to have to figure out how to make that work. Let's just hope I didn't make up one that don't work well. Because I just made this one up. So it's still 2. The amplitude is still 2 to get to the top one or get to the bottom one from the x-axis. And then it definitely shifted back. Because right now, if it was where it was supposed to be, it would be here. Does that make sense? It's supposed to be next to the y-axis, not in the middle of it. How much did the bottom of that parabola move? It moved pi. Does everybody see that? It moved from being here to here. That's pi to the left, isn't it? Okay. All right, so we have x equals pi. How do I turn that into a parentheses? Don't even think about the period, just think about the parentheses. How do I turn that into a parentheses? X minus pi. Okay. Now here's the problem. This particular problem still has the same issue that that one had. Okay? Your period did not change just because you chose a different function. It is still 3 pi long. That does not change. But what has to happen is I still need that 2/3 in front of x. So I got to figure out what goes in front of this to make that work. Now, sometimes that can be easy and sometimes that can be hard. On this one, it's easy. I need it to be 2/3 x minus something in front of pi so that it will come out and do what I need it to do. It needs to come out to be the right information. I know when I take 2/3 and I put it down here and flip it, it came out 3 pi. Everybody see that? But when I move this pi over here and flip and multiply, I need it all to go away and come back to be pi. So think that through one more time. Let me say that again. When I move this over here, I'm going to flip and multiply that, right? And that's going to make it 1. So what does this have to be so that when you flip and multiply, it'll go away? 3/2. So in other words, you just got to get these two things to divide out to be that number, whatever it takes. Whatever it takes, these two numbers have to divide out to make that number. If they don't divide out to make that number, then your right-left shift didn't work.
Because you take it and you flip multiply to the other side and then they cancel.
Exactly. So I'm thinking, what divided by that makes 1? The reciprocal. Now, if it had been any other number, I'd have to flip, multiply, and figure it out. But because it's that number, that was a little obvious. So my parentheses, well, it's right here. 2/3 x minus 3/2 pi. So that's the tricky part. And that's why when you're on a multiple choice test, you should go through and rule out the answers that don't make sense first. Like, make sure all the amplitudes are right. Make sure all the right-left stuff's right. Make sure, you know, every little piece fits. Make sure the period fits. No, because when you take this, let's just make sure. Okay, I set that equal to 0, right? Okay, I'm going to move that over there. You're right.
I was wondering about that same thing because I was like trying to figure out how it's going.
Okay, we're going to make that work now. I believe you're right. Let me try it this way. So when I flip, multiply. Now it does. You're right. So be careful, because that's why you want to go back and do what I was just showing here, because you might put it in upside down by mistake. It's so easy to do that. It's only going to cancel if they're both the same, right? So that when you flip it, these cancel, these cancel. So that's why you want to go back and put it in there and set it equal to 0 and solve it and make sure it gives you what you want, because sometimes it's a little tricky. It can be a little tricky. All right. Again, I could have started in a lot of places. I could have come way over here and chose that one as my first one. And that would have been 2 pi to the right. That could cause a whole, thing of, I need a 2 here instead of a 1. So you're just going to have to sit there and do some math. What divided by 2/3 makes 2, for example? And then you'll get the math. And that'll fill in your number. Alright, let's try tangent. Or cotangent, or both. We'll make it fit either one. Okay. Okay, what did I do?
You hit the little single page display.
Thank you. I don't use that feature much, so you knew something that's good, because I didn't know what I did. I didn't know that. I didn't know that's what that did. I don't never use that feature. All right, I think this will work with what I'm wanting, and the numbers aren't too bad on this one. I hope. Who goes uphill or downhill makes a difference, okay? Stick with the function that you think it is. So when you think tangent or cotangent, who goes downhill? All right, let's do him first.
Yeah, I'm gonna set up for about this. I don't like x-axis flip. It goes down. I don't know. I just did it.
Okay. So cotangent normally goes down. All right. Now, I want to switch this up just a little bit. If I have time to pass stuff back today, yes. Okay, pretend those two dots are at the same place. I can't make it work. Yeah, -2. Pretend they're at -2. Okay, so if they are at -2 and -2's in the middle, does that tell me something? That's my midline, okay? That's important to know because my midline is supposed to be on 0 every time. All these functions, midlines are on 0 unless it shifts up and down.
So it's down to...
Everybody agree?
Yes.
That this is down to? Mm-hmm.
So always, that's your midline?
Mm-hmm. Mm-hmm. Now, to know if it's been stretched or horizontally, vertically, all that, you would have to look at the dot on each side of this to know that. And I'm not going to do that. So I'm going to put it on one. I'm going to put it there.
Like, pretend the dots are in the right place.
Yeah, I'm great that way. Alright, so if these points are kind of evenly spaced on each side of this and it just looks like it changed 1, that means you must have multiplied by 1. So I don't need anything in front. I thought it'd be good to do one that had an amplitude of 1. Alright, so now all we got to do is figure out if there's right-left motion versus up-down motion. We've got the up-down, so let's do the left-right. Cotangent is supposed to have a vertical asymptote on the y-axis. Is my vertical asymptote on the y-axis?
Yes.
Then we're good. It doesn't need anything extra to make it shift right or left. It's on the axis. So we're going to focus on this piece right here because it's on the axis. There's no left, right. We just got to get the period right and we're good.
I feel like y equals cotangent. Just none and just...
What do you, that's,
I said like just y equals cotangent.
that point's in the middle.
Okay. 'Cause I was like, what? 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 '
That's why I was talking about that's the midline. Goes through the middle. So how long is this? One piece.
Pi.
Pi. How long is the period supposed to be on? It's supposed to be pi. It's supposed to be pi divided by omega. So guess what's in front of x in this problem?
1.
1. Now, let's go back and do tangent. The only difference is that parentheses, y'all. The amplitude does not change. The number on the end does not change just because I changed functions. Okay? But it did reflect. Where? In front of 10. Yep. Well, you're right. You're right. Because my amplitude flipped it, right? Because it's negative in front. The amplitude's still 1, but it reflected. Tangent's supposed to go uphill. This isn't going uphill, so it has to have a negative in front. Everybody with me? Okay. Now, here's the next thing. What else is different about tangent? Tangent does this. So, hold on. I mean, as far as like, let me do that again. That's cotangent. So you see why it's different than tangent? Tangent's this. Okay? See how the reflection? So, and when I did the cotangent one, I wanted to focus on it being over here, like it's moved over to here. That made it cotangent. When I shift this back this way and put that through the origin, that makes it tangent. Mine's not through the origin, is it? See, tangent's supposed to go uphill and through the origin. Mine is not going uphill. That's why I put a negative in front, and it's shifted over.
Like it's gonna.
Right, it's going to move over to the right. How much? Well, yep, because if you want this point right here to come back to that axis right there. See that? It's here. I need it there. Or I can say it's there and I need it there. I could go either way. You want to go to the right? Okay. So how much from here to here it went over is pi over 2. Does everybody see that that inflection point was supposed to be at the origin? It's gone over pi over 2 and down 2. Pick one point that's the most important point on the graph, and it shows you everything you need to know about up, down, left, right. In this problem, it's this inflection point. So since it's supposed to be at the origin, but it's gone over here, that pi over 2 has something to do with my right-left motion. So we know it's going to the right. It would be this. Right? Everybody agree? That's what makes things look at the right, because it's subtraction. But do I need that 2 here to make this work? Well, let's see. The period in this problem is pi, because it's pi long for one piece. So therefore, if I put that 2 in front, will it still be pi? No, it wouldn't, would it? So therefore, I don't put it in front. Whoop, I wrote in the wrong one. I'm over here. Right here. So the graphs will be similar for the two functions. They'll be similar, but you can make totally two different functions out of it depending on which one you think it is. So if they don't tell you which one you want to do, you're going to have to first figure out, well, how many of these answers can I rule out because they didn't go up, down, left, or right the way it's supposed to? And then make sure the period matches the one you chose. And that's where knowing the information on that little foldable sheet is very important, because it focuses you on key features, like that inflection point's really important in the middle of this graph, because that's really what's moving up, down, left, and right. In this problem, it's the maxes and the mins. You need to half the distance between the max and the min so you know where your midline is, and then you can count how tall your altitude is. In this one, it's just picking a piece. And it doesn't matter if you pick a piece that goes up first or down first. You could do it either way. It'll make a different function. Still graph the same. There are literally hundreds of different answers to the question.
The biggest thing I didn't understand the whole time we were doing those quizzes that I understand now is that when you would do it, if it flipped over the x-axis, the numbers would automatically flip it for you.
Mm-hmm.
I couldn't know that.
Yep.
I thought I had to flip it myself. But I did that on like every single one of them, and I was like, I just didn't get it, but now I get it.
You get it? Okay. So, I think that kind of hits the highlights of what you need to know. So I'm going to stop the video, hand out the material, and we're going to go over the directions, okay?